Hello, it's your amigo Lee Halliday, and in this video we're going to be looking at how to store geographic data inside of a MongoDB database so that we can query it, finding nearby locations, we can index it to make sure it's efficient, fast, snappy, and that we can even validate the incoming data so that we know that whatever we're saving in our database conforms to the sort of data structure or schema that we're looking for. So we're going to be playing mostly in Compass today, but this all started because I've been working on this bear sighting map that I originally built using Postgres. So my whole career I've mostly been working with relational databases, Postgres, MySQL, even Oracle. But I wanted to try to convert this to MongoDB, so I don't pretend to be an expert. It's just what I've sort of learned along the way of building out this demo. So the way this works, you can sort of click on the map and it will add and save the location of this bear sighting so that you can warn your fellow campers where the bears are. It's obviously not a real app, but I suppose it could be. But it got me thinking, how do I store these positions on the map within MongoDB? So I started researching. They've got awesome documentation on this, and they have a specified way to store GeoJSON objects. So GeoJSON is a spec that basically describes how you should encode or store your geographic data. And for the most part, it looks like this. You've got a type, and there's different types, like you've got a line, a polygon, etc. We're going to be looking at a point, which is just one position on the map, along with that point's coordinates. So your longitude and your latitude. So the two numbers that we store there. So going back here, it describes that you need sort of a type, coordinates, same thing we were just looking at. So that's where, when we go back to Compass, that's how we ended up with this. Each of our sort of documents within this collection has a location, that's your GeoJSON data, which has the type, point, the array of coordinates, and then you can store whatever else you want here as well, like I stored created at when was this bear sighting added to the map. So the first thing we want to do maybe is query, find me all the nearby locations to, let's just say to this location. So you could sort of maybe find other bears in the area, I guess you could say. So the way you query here is you tell it which field you're querying on, and we are going to be looking for a near query. And near query, you have to tell it what geometry you're looking for. Geometry gets really nested here, so it's a little bit hard to read, but so geometry, we've got what type of geometry, we're looking for a point, and then we've got our coordinates. So it ends up looking very much like what our data looks like here below. So we'll say minus 79.3 for our longitude, 43.6 for latitude, and we'll try to run this, and we get an error. Error processing query, GeoNear, unable to find index. So first discovery, I guess you can't query geographic data in MongoDB without an index, so let's go add one. So we'll pop over here to indexes, we'll create an index, we'll just call it location, and we'll put that on our location field. And what type of index is it? It's a 2D sphere. So that's what you use in MongoDB to index geographic data. So there's other options that we won't worry about too much. If you've already got a ton of data, you probably want to build the index in the background, but I only have 27 sort of test documents, so it doesn't really matter. So we'll add this, pop back over, let's see if we can run this now, find, and it's now working. So it's finding, I think, pretty much all of these locations. So how can we get a little bit more specific and say, I only want ones that are within 1 kilometer. So you can come back up here to this level and you can add another option here called the max distance. And this works in meters. So if you want 1 kilometer, you'd do 1,000 meters. So if I find this, I get none. So you'd think I'd at least find that one, but it's because I didn't put the full sort of decimal places in here. So why don't we bump it up to 10 kilometers? So now I'm finding the 1. If I add another 0, Now I got 100 kilometers. So now I'm finding that there's 9 bear sightings within 100 kilometers of these coordinates right here. So 2 problems solved is 3. We know how to store GeoJSON data, so location, type with a point, coordinates, etc. We know how to query it, and we know how to index it so that it's efficient. But now let's talk about validation, because what I discovered is that there's rules to these numbers. So first rule is that a valid longitude is values between -180 and 180, and a latitude is -90 and positive 90. And then even our type field, there's only certain types of data that you can store, and in our case we want to limit it to points. So back when I first learned MongoDB 8 years ago, I think, something like that, I don't know if this existed or not, but it does exist now, and it's pretty cool. MongoDB is schemaless, meaning you can sort of take your documents and add nested data, different fields in any which way you want, as opposed to, say, Postgres, where you have to define your schema. It's going to have these columns with these data types, and these ones can be null, these ones can't. MongoDB is a little bit more freeform, but sometimes you want that assurance that the data being put in there is valid. And a good place to put that is at the database level, because that ensures that there's nothing getting passed, nothing invalid being put in here. So MongoDB, we can use validation, and it all starts with JSON schema. So JSON schema, first of all, is another spec. So you've got all the info here that I obviously have not read, but it basically describes how the JSON's data looks like. Sort of the form it takes on, what data types, different limitations to it. So we can do JSON schema. And as we add things down below, it's going to show us these documents pass validation. Here's one that doesn't. So you can sort of make sure that the rules you're describing match your actual data. So at the top level, what does each document look like? So it's a BSON, which I think stands for binary JSON, but it's an object, just like that. And this object has properties, which we'll describe in a sec, but we can say which properties are required or not. So this is an array of fields, so we'll say that our location is required, and why don't we also say that our created at field is required, just like that. Okay, so our data is still valid. Let's say that we added another one, hello or name or something. So now we can see that we've got one that's failing validation. So now I guess you could talk about what happens when it tries to save invalid data. So you can control that here. Do you want to error out, like stop this from being put in, or just give a warning? And what level of validation? So off meaning just ignore everything. So I'm not even sure why you'd validate if it's off. Moderate meaning existing invalid documents are fine, but new documents will be validated. Strict meaning everything must be valid, everything old and new data must conform. So we're going to go with errors and the most strict. So let's make it valid again. Okay, properties. So we have 2 properties, right? We've got location and we have our created at. Why don't we start with the easy one, the created at. So this has a BSON type of date, and that's pretty much all we need to add to it, I think, at this point. Let's get into our location, which is a little bit more complicated, right? So location is also an object, and this object has required fields. So what fields does it have? It has a type, and it has, what was the other one again? Coordinates. Coordinates. Okay, and now we can get into defining what these properties look like. So we can say that our type has a BSON type of string, but we don't want it to be any string, right? We want it to be specifically the word point. So we can describe enum, which means it must be one of these enumerated values. And here we can define an array of what valid values we want. So we could say point. Cool, and that, let me just save this so it formats it nicely. So we're still all valid. Say we switch this. Now you can see that it's invalid because it doesn't match the enum type. I sort of wish that it would tell you what field and exactly why it's invalid. I don't know why it doesn't tell you that, but it doesn't. Okay. All right, so the type is handled. Now let's get into the coordinates. Okay, so coordinates, what type of data is that? If we look at this one here, it is an array. So that will be our GeoJSON type. Array. Just like that. And keep going. So when you have an array, you can say how many items should be able to be put in that array. So we've got min items, we'll say 2. So if we say 4, it should tell us invalid, cool, but 2 should be good. Max, also 2, because we want exactly 2. So if you limit the min and max to both 2, you're going to be okay. And then we want to say, what should the items look like inside of this? So if all items should be the same, you can do an object and you can give it a GeoJSON type of double, which I think is what represents sort of like a decimal or a float. But we've got specific rules around these, where the first one is minus 180 to 180, second one is minus 90 to positive 90. So what we can actually do is, instead of making it an object, we can say that we've got an array, and we can describe each one individually. So the first one will be a double, and then we can actually set its minimum value to be that, and its maximum value to be 180, like this. Just gonna format things nicer. There we go. And then we can describe our second one. So this would be our latitude. So GeoJSON type of double, again, but this one has a minimum of minus 90 and a maximum of 90. So we're still good again. So let's just make sure that it's actually working. Let's see that this is positive 43. So why don't we just, for a second, make it 30. So now it's invalid, great, so it seems to be working. And there we go. So what we've just put together, it's pretty big now, but we're basically describing what our data should look like. Each document in relational databases would be like each record is an object with these 2 fields that are required. And what do those 2 fields look like? They look like this. But because MongoDB are nested data, sort of JSON documents, it's objects in objects which have arrays, etc. So we described out the full extent of what our data looks like. And at the end of the day, what we've done is we've learned how to store our data, what it should look like, how to query it to find nearby locations, how to add indexes so that A, it's efficient, but B, it also just works. And then we've learned how to validate this GeoJSON data so that we're sure that the data being put into our database conforms to the way that MongoDB expects it to arrive. And that's important because indexes rely on the data looking a certain way, but also just doesn't make sense. Like a longitude with a number of minus 200 doesn't show up on the Earth anywhere. So we need to make sure that the data we're inserting matches. That was the video for today, and this is sort of the beginning of me building out, adding a MongoDB backend to this bear sighting React Google Maps application, and that video will be coming next week. Hope you enjoyed the video. Thank you very much. Take care. Bye.